Aliens. For centuries we have asked ourselves questions, such as, why are we here? Are we alone? Is extraterrestrial life possible? What can we learn from other beings? Are aliens scary? I bet they are. Or are they cool, like Mork, Stitch, Alf, and E.T.? That would be sweet. What are they? Do they exist?
Aliens have become an important aspect of modern pop culture. They appear in our books, television shows, radio programs, and movies. You may think that this is a recent phenomenon, but the possibility of other life has been pondered for centuries. Historians have found references to extraterrestrial life dating back to 27,000 BC.
Cave drawings and hieroglyphics depicting alien life and abductions have spanned across continents.
This is from Australia, 3000 BC. The Sahara Desert, 6000 BC. Italy, 10,000 BC. Egypt, 2600 BC. Depictions of extraterrestrial life even appear in religious Renaissance paintings. These are just a few of the countless images created throughout history that show evidence of aliens on Earth.
We may never know if civilized life exists, but we can make a generalized estimation based on probability.
An equation known as the Drake equation outlines the probability of such a phenomenon. We can find the probability that life exists on another planet, represented by n, and we can find that by multiplying a series of variables. R represents the average rate of a star formation per year in our galaxy. F sub p is the fraction of those stars that have planets. N sub e is the average number of planets that can potentially support life. F sub L is the fraction of the above that actually go on to develop life at some point. F sub I is the fraction of the above that actually go on to develop intelligent life. F sub C is the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. And then finally L, the length of time such civilizations release detectable signals into space. Now let's plug in some real values for those variables. We can substitute 10 for R because there are 10 stars formed each year in our galaxy. We'll substitute 0.5 for F sub P because half of the stars formed will actually have planets. We'll substitute 2 for N sub E because there will be 2 planets per star that are capable of developing life. We'll substitute 1 for F sub L because over time, 100% of these planets will actually develop life. We'll substitute 0.01 for F sub I because 1% of all these planets will develop intelligent life. We'll then substitute 0.01 again for F sub C because 1% of the above planets will develop the technology to communicate. And then we'll substitute 10,000 years for L because on average a civilization would be able to communicate for about 10,000 years. When you add up all the numbers, we can find that there's probably about 10 civilizations that have the capability to communicate with us. 10 civilizations in our entire galaxy. So there's probably other planets with aliens in it. There's probably 10 planets at least that have the capability of making microwaves, just like we do, and they can have hot pockets. And there's 10 other planets that can also make up this equation and think about us existing. And